on. I'm going to start over here because I can't. Okay. So you need to know how to do basic area first. I had another marker. Where did it go? Oh, it's up. So first off, this is a triangle. You need a right triangle in order to do area. So area is 1/2 the base, which is little b, times h, which is the height. In this case, for the area of a two-dimensional triangle, we are looking where it's touching the 90-degree angles. So in this case, I have 1/2 times 5 times 12. So this is 1/2 times 60, which is 30. 30 inches squared. And the reason that it's inches squared, in case you've ever wondered, this is 5 inches times 12 inches. 5 inches times 12 inches. Well, 5 times 12 is 60. And inch times an inch. Inch times an inch. 7 times 7 is 7 squared. 12 times 12 is 12 squared. Inch times inch is inch squared. That's how they end up with that. Everybody with me? Okay, number 3. This is a rectangle. The area of a rectangle is little b times h. Little b being the base of the rectangle. Again, we're looking where the two sides meet the right angle. So this is area equals 8 times 12. Area equals 96 inches squared. I think I did that math right. 8 times 2 is 6, carry the 1. Yep, okay. Questions there. Everybody with me? Number 2. This is a trapezoid. 1/2 times the height times b1 plus b2. So there's two bases in a trapezoid. So now I have area equals 1/2 times the height, which is 8, 6 plus 20. So first, I'm going to do 1/2 times 8, which is 4, times 26. So my area is 4 times 6 is 4, carry the 2, 104 inches squared. Push these boxes out of the way. And last but not least, is this a right triangle? No. But you need to have some type of right triangle in there. So there is superfluous information, which means there's more information than we need. What number don't we need in this? The 5. We only care about what's touching the right angle. Area equals 1/2 times 10 times 3. Area equals 1/2 times 30. Area equals 15 inches squared. Questions on how I got those? Yes, no, maybe so. Test these out. I want mine copied. Okay, this is not from our book because I do not like our book for this. I'm being honest. Our book does a poor job of explaining this, and now I'm going rogue. It's Mr. H's class, so I can do whatever I want. That's what you need to understand. Right now, this is my class. I do what I want. Did you get? Everybody should have one. 1, 2, 3, 4, 5. Oh, there were 7. Yes, you said that. I forgot about that. Okay, we're good. Go in there. So it is 4/22. It's almost my birthday.
Your birthday?
My birthday.
When's your birthday?
On the day that I was born.
Specific date.
Duh.
Specific date, please.
Oh, I was born on a Monday. 4/22. Our objective today.
Your birthday in May?
No. I can find
Oh wait, I know when it is.
the area of. Let's try again. I can find the surface area of prisms. So today we are talking about the surface area of prisms. We will probably spend 2 days on this simply because we have 20 minutes and I expect to be talking for 10, at least.
4/22/29.
That's not it. I was talking about my birthday, and then 29 got put up there.
Wait, birthday?
Birthing day. What don't you understand, Julian? Birthing day.
Birthday.
Birthing day. I don't know.
It's birthday.
Why can't I have fun, Julian? Why you gotta? Why no? Why you gotta crush my fun? You just want to suck the fun out of my soul, and I don't like that. I'm trying to have so. Oh, there's a pencil there. Give me that.
Well,
Yeah.
I hope you know
Speaking of
life.
fun, give me that. Give me that. Give me that.
I wasn't even trying for real.
Nice.
Okay.
Oh, I went the wrong way. Get that again. I think I broke.
What are the odds can you get it in like?
I should have gotten it the
Eraser
first time.
in.
There it is.
Oh.
Okay. Okay.
I don't like logic because it makes you like. Because like it gives you like a big head and I can't do it.
I already have a big head. Okay, here we go. So, first things first.
No.
Ow. A prism. This unit, we are talking about three-dimensional figures. So what we had on the board so far were two-dimensional figures, flat. We can draw them without depth, okay? It can be, what's funny now?
I'm still thinking about birthday.
Oh my gosh. So, two-dimensional figure can have height and width, or it can have height and a base, but it has no depth. This room is a three-dimensional figure because it has a base over here, it has height, and it then goes deep. The front wall is a two-dimensional figure. A prism is a three-dimensional figure. So what makes something a prism? It is a polyhedron with two congruent bases. Okay? In prisms, there are bases and faces. Okay, let me move that away. Okay. The only thing that makes it a prism, is it is a polyhedron, which sounds like what? Polygon, which have straight sides, no curves, don't intersect. A circle, is that a polygon?
What?
Is a circle a polygon? No, a circle has a curve. As soon as there's a curve, it is not a polygon. So polygons, triangles, squares, rectangles,
Anything with an A.
yes, except that it can't have a curve.
Uh-huh.
Because I mean, I could draw something like this, right?
Not all angles.
So all angles, okay. So any of our shapes that we've talked about, okay? Polyhedron means it's that three-dimensional figure made up of polygons. We are going to specifically talk about two, okay? We are going to talk about a rectangular prism. And, let's just do the rectangular prism first. So I'm going to draw it, and then we'll go from there. I wish I had different color markers. I need something other than these two blue markers that are going to be too similar. Does anybody see a black or anything else? No. Okay. So this will have to work.
There's a green one right there.
Huh?
There's a green one right there.
Yeah, these are both blue. But okay, so a rectangular prism. Let's start with the solid. Okay? What is that?
An actual green one.
Yeah. Good throw, bad catch. Okay, so we have things called the solid. Okay, the solid is your traditional three-dimensional figure. Okay, so when I draw this, I'm going to start with a rectangle. Okay, so that is a rectangular prism. For it to be a rectangular prism, one, it has to be made up of polygons. What shapes are my rectangular prism made out of?
Rectangles?
Rectangles. But rectangular prism is named not because all of the faces are named rectangles, but because the bases are. So in this case, my bases are the congruent things. This bottom here and this top here. So this and this. Okay, the top of a box and the bottom of a box. So if I'm looking at these boxes, the top and the bottom of the box are the congruent sides. In a rectangular prism though, the opposite sides are always congruent. Okay, so that's a solid. But then we have something called a net drawing. And let me tell you, I am good at math. I am good at math. My brain struggles with net drawings. Most students that I work with do not. You guys will do much better at this than I do. I don't know why, my brain struggles with it. Okay? So what a net is unfolded. So it's an unfolded picture of this. So here we go. So I'm going to have my base, which is a rectangle. It's a long rectangle. Everybody with me? So that's this part. Then I'm going to lay it flat. Then I have a small rectangle on this side. I'm going to lay this side flat. I have a small rectangle on this side. Everybody with me? So now I've got this part, this part, this part. Well, then I have this big long rectangle again. It's going to unfold this way. So right now, this is a base. This is a base. Everybody still with me? Then I've got another rectangle here. Another rectangle here. Does this work and will this fold up to a box?
Yes.
Yeah. So these fold, this folds, that folds up, that folds on top. This is a net drawing. But right now we only have the bases. So now I'm asking you about the faces. Guess what? The faces are all of the stuff that is not a base. Everybody with me? Do you think you'd be mad if I erased this?
No.
Please don't be mad. No, I'm gonna leave it. Sorry. Okay, so rectangular prism. The bases are the same, have to be congruent. It's all made of rectangles, but the bases are these triangles. They have to be, and you know what? Two congruent, I'm screwed up. We're gonna add a word. Because for it to be a prism, two congruent parallel bases. They have to be parallel. Okay? So when you think about a box, think about this room, the ceiling and the floor. Yeah, those are parallel, or at least if they're not, something's wrong with our foundation. Right? Okay? So now we're going to do another prism, and you're going to help me name it. Okay? Okay. So, this is where congruent parallel matters. What type of prism is this?
Triangle.
It is a triangular prism. Now, listen, a lot of students have trouble with this because they go, but Mr. H, isn't this the base right here? It's sitting on that. Sure it is. It is sitting on that. That doesn't mean it's the base. Is there something above it that's parallel? No, there's nothing above it. There's this line. But this triangle and this triangle are exactly the same and are parallel. So now, how would I draw this? Well, watch this. So I'm going to start with my triangle. Or no, that's not a triangle, Mr. H. Starting with this rectangle. Still with me? Will that work?
Yes.
I mean, will it?
Yes.
Okay. What are the bases? What are the bases?
Triangle, like.
The triangles. Those are my bases. That's important. Notice, am I using little b?
No.
Huh. There's a reason. What are the faces then? The rectangles, all the other stuff. So in a prism, there will always be two bases, and then however many faces. Could I draw a hexagonal or a pentagonal prism? Well, let's see.
It's in a house.
I mean, I could. In a hexagonal prism, wow. In a pentagonal prism, how many bases do I have? How many bases?
Why not?
Two. This is a base. This is a base. How many faces would I have? 5. It's determined by the number of sides of your base. Okay? Will we do this? No, because we don't really know how to solve for area of this. We know how to solve for the area of our bases. That's important. Oh my gosh, we're almost out of time.
Yes.
Okay, we're gonna do one more thing and that's it. Don't lose these papers because we're gonna use these. Okay? So,
No problem.
first, big B is going to stand, and this is important. Big B is area of the base. Lateral area, which is abbreviated, I know this is going to come as a shock, as LA. Lateral area is the area of the sum of all faces. Okay, so we have area of a base. We have lateral area, which is the area of all of the faces added together.
What is that?
Oh.
I have no
saw
idea.
a ladder.
Are there questions?
No.
Okay, this is where we're going to stop. Make sure you bring these sheets back for tomorrow. Okay, you have no homework. You can take a look through this so you can see what it is, but this is what we're going to be using tomorrow. Love y'all. Good job.